Here we have a paper Titanic crossing the sea, which is more fragile than a steel one. Yet, the steel one would also be troubled by biofouling, which may slow the speed of the ship, corrode the ship's body, and make it more fragile. How could we save our Grand Titanic? Let's begin with biofouling in ships. It is a mixture of algae, bacteria, or any marine microorganisms in colonies. Biofouling increases their hydraulic volumes, which results in larger drag forces, which ultimately leads to greater fuel consumption. But this issue never troubles Mr. Sharp. He is also an expert in swimming, with speeds up to 30% faster than that of the Titanic. All of these are contributed by his fantastic high functional skin. How does it work? Well, shark skin is composed of many small scales called dermal denticles. A CFD analysis of this structure showed that denticles are able to control naturally occurring turbulences and reduces wall friction. In terms of anti-biofouling, the flexion of the scales during movement provides poor anchor points for marine microorganisms to latch onto. But how can we provide our Titanic with skin like Mr. Shark's? Marine plants are highly adaptive and able to cling onto different surfaces. To solve the issue, scientists transplanted the microstructure of shark skin with the help of 3D printing. They scanned and modeled the structure of shark skin, and the 3D structures of denticles and substrate were printed with functional polymers of different mechanical properties. Then, the scientists managed to fabricate an artificial shark skin performing 4% faster than equivalent smooth surface in speed test. Shark skin can be effectively utilized in the healthcare and transport industry. In medical applications, common surfaces such as protective apparel and surgical equipment experience biofouling, which causes about 26% of microbial infections. By implementing shark-like pattern in the medical field, we can create a more sterile environment. In marine transportation industry, by utilizing 3D printed shark skin on their hulls and surfaces, we will reduce locomotive drag and consequently the fuel consumption worldwide, which would create a much greener future. Structures submerged in water such as docks, coastal buildings, and even the city of Venice are at threat of biofouling. The attachment of microbes on these surfaces together with environmental factors severely reduce the lifespan of these structures. By implementing the shark skin technology onto these surfaces, we can create a hydrophobic surface with poor anchor points which will eliminate the issue of biofouling. Now, let's go back to our Titanic. By utilizing 3D printed shark skin on the surface, the wall friction has been reduced, which makes Titanic sail faster than before. At the same time, with the promotion of anti-biofouling, the corrosion of the ship's body has been limited.